It won't be long. So the first thing we write down is composite numbers. And if simply under this, all you need to write is numbers that have more than 2 factors. Or, children, or numbers that are not prime. The one thing you have to be careful with that is the number 1. 1 is not prime, and it is not composite either. When we talk about prime numbers have to have exactly 2 factors. Composite numbers have to have more than 2 factors. But number 1 only has 1 factor, and that is itself. So 1 is like the excluded thing in all this. 1 is neither prime nor composite. Other than that, what would be an example of composite numbers?
2.
No, 2 is actually a prime number. 2 is the only even prime number. 4, because 2 times 2. 3 is not, because it's a prime number, because it's only 1 and 3. 6, any other even number is going to be prime. 8, 10, 12, but don't forget you also have 9, because 3 times 3. You also have 15 because of 3 times 5, and so on and so on. There's gobs of them. But that is that. Now, with that being said, now we need a blank piece of paper, because this is what really today is about. And on top of this, write prime factorization. Prime factorization. And we have a couple other names for this as well, and we probably should jot them down. It is also known as product of primes. Also known as division by primes. Also known as factor trees, or the tree thing. They all mean the same thing. They are all the same thing. And what it is, you had some problems like that on today's assignment, or one problem like this. You are breaking a number down. Breaking a number down so that it is all prime number factors. That is what this whole deal is. Oh boy. I don't think I can get all the way over there. Make big groups. Breaking a number down so that it's all prime number factors, and it's a really pretty simple process, but we have to explain a couple of them. Let's say you have the number 6. And you are supposed to prime factorize. Prime factorize. Well, one way to do it is what we call the factor tree. In other words, you break it down and put little things here, and you just say to yourself, what times what gives me 6? Well, that's pretty simple. The only combination you have is 2 times 3. If these are both prime numbers, you can stop, and the prime factorization of 6 is 2 times 3. That is it. Here is your prime factorization. Not always quite that simple because it's going to be a little bit more involved. How about the number 12? Well, if you break down the number 12, there's a bunch of different ways you can do it. It doesn't matter which way you do it. In the end, you'll come up with the same answer. Let's just say you said 12 is 3 times 4. Well, you can stop with 3 because it's a prime number, but you can't stop with 4 because 4 can be broken down into 2 times 2. And 2 times 2, those are both prime numbers, and you can stop there. So the prime factorization of 12 is 2 times 2 times 3. Now please be very careful here. Sometimes I get kids going, well, 3 can be broken down into 1 times 3. But you have to understand what happens if you start doing that is you'll never stop. Okay, first of all, 1's not prime or composite. Okay, but you can keep doing 1 times 3 forever. You're not going to get that. No, 1 will never be part of this process. Okay, it's got to be prime numbers, and that's 2, 3, all those sort of things. And again, let me show you 12. 12, let's say you didn't do 3, 4, let's say you did 6 times 2. Well, you could stop with 2, and then you break down 6, and it's 2 times 3. You still get the same thing you got up there, 2 2's and a 3. And generally, when you write it down, if you do it from least to greatest, it just makes correcting a whole lot easier. Now, sometimes they get a little bit more involved, like number 36. 36 there is just God's way to do 36. If you were breaking down 36 Lacey Robbins, what would you break it down into? What times what?
6 times 6.
All right, so you go 6 times 6, and then 6's are not prime, so you have to break those, Charlie, too.
2 times 3.
2 times 3, and 6 is
2 times 3.
2 times 3. And those are all prime, so you can stop. It's good to stay organized because otherwise you will get yourself all mixed up. Now understand, because this looks like a tree, this is what we call our factor trees. Because it looks like a tree, hence factor trees. To which you would ask, well, what about division by primes? What does that have to do with it? Division by primes is another way to find an answer to prime factorize something. And it's just like it says, it is dividing by primes. If you have 36, what prime number can you divide it by? And I always say if it's even, always cut it in half, because cutting things in half are easy. So I can divide this by 2 and get 18. And then I keep doing that same thing until I get down to just prime numbers. You have to divide by a prime number, and 18 can be cut in half again. It's 2, and you end up with a 9. 2 doesn't go in 9, but what prime number does? 3. And you end up with a 3 at the end here, and though that's prime, so when you stop, you end up with 2 times 2 times 3 times 3. It's the same answer, just done a little different way. And this, ladies and gentlemen, I guess we'll do it pink since I did it. This is division by primes. Factor trees, division by primes, you get the same answer no matter what way you kind of do it there. Let's do the number 60. Let's do 60 by division by primes. And again, I would always, if it's even, I would cut it in half. It's just the simplest way to do. You could do 3 if you really wanted to and get 20, but to me, even is just the way to go. Cut 600 in half, or 60 in half, you get 30. Cut 30 in half, you get 15. And then what would you divide 15 by? You have your choice. Even? Yeah, 3 and you get 5. And whenever you get to a prime number at the top, you can stop. You know that your prime factorization is 2 times 2 times 3 times 5. 2 times 2 times 3 times 5. That is the prime factorization of 60. Tree thing and division by prime. Is there another one in here? Let's look and see. It doesn't appear to do anything too crazy. Oh, how about this one? Let's go harder. 125. And sometimes they'll give you the choice. Sometimes they'll say use division by prime. Sometimes they'll say make a factor tree. Your choice. What should I do on this one? What would you do? Sam? Would you go division by primes or you go factor tree?
Decisions. Fact.
And so then what times what gives you 125? It's not the easiest thing in the world either. And by what times what gives you 125? Now you might want to, because it's not that easy, you may want to say, well, let's use division by primes because I know what number goes into 125. 5. And then when you do 5 into that, you end up with 25. And then what can you break 25 down by? 5 times 5. So 125 actually breaks down to 5 times 5 times 5. If you did the tree, obviously the only way to break it is really 5 times 25. Cut it from